Welcome to Contextual Electronics. My name is Chris Gamble. Today we're going to continue on with Getting to Blinky 5.0. Today we're going to be actually creating a schematic symbol, and symbol is a great word to start with because that really helps to explain what a schematic is in the first place. Schematic is a symbolic representation of an actual physical circuit that you're going to be laying out later. Now, it's kind of hard at the beginning to differentiate between the schematic and then how it actually attaches to that physical thing. Should the package itself, if there's an 8-pin package, should all of the pins be in order? And we'll take a look at that here. Do I need to actually connect these things together in the real world if a schematic symbol pin is just a virtual pin? And so let's take a look at what this schematic actually looks like for this Getting to Blinky 5.0 video, and we'll explain it more from there. So this is the same circuit we used in Getting to Blinky 3.0 and 4.0. It's a simple 555 circuit. It's literally just going to blink on and off. If you don't know, the 555 is a famous chip that's been around since the 70s. It's really simple. It's basically just a timing chip. The resistors and the capacitors that we have on the left side here, these are basically just helping you set up the timing in order to how we should turn pin 3 on and off, and that'll actually blink the LED. Now there are going to be some differences here. We're going to use a 7555 instead of a 555, and that's because that'll allow us to use a lower battery voltage. So instead of 9 volts, we'll say 3 volts, but we'll just call this stuff battery and 555 and use them interchangeably here. But the first thing we need to do is we actually need to make this symbol. So a big part of Getting to Blinky is actually doing each and every part of the process for when we want to get to a final PCB. And so in this case, that means that we need to actually make the symbol itself. So let's go over to KiCad and take a look at what this looks like here. Make this bigger. All right, so we're going to open up the schematic. And right now we have a blank canvas here. If we hit A, and you can see I'm going to be showing all of my keystrokes in the upper right there, we can actually take a look at the different things. Now you can see I've already done this once today, but if we type in 555, we can see this is the original. This is the one that is already built in here. Now we could use this, but that's not really that fun. Actually, in KiCad 3.0 and 4.0, the libraries have gotten a lot better, so you often will be able to find the parts you're looking for here. But we're going to go and actually build our own component here. It'll be pretty similar, but that's okay. We're going to still build it ourselves. So we'll just delete this one, and let's go into the library edit, the schematic symbol editor rather. Okay, so now we're in the symbol editor. First thing we need to do is we actually need to make a new library. See over here on the left side, we have all of the existing libraries. These are what came default with your build. So if you don't see these, that means that when you installed KiCad, you probably had either an error or you chose not to install them or something, and we can have other videos about how to go and install them after the fact. But more likely than not, you have the actual symbol libraries already installed. If we open one of these up here, let's just go into, what's a good one? How about analog switch? You see in here, if we double click, we actually have the schematic symbol. Like I said, these are all symbolic versions of the actual physical thing that'll be out there, right? So this looks like a 20-ish pin, it's a 24-pin part you see down here. So this one's already paired with a footprint. We'll get to that later. But this is a 24-pin part. You see that not all of these pins are in order here. So right, so the pin number is actually corresponding to how the chip is laid out and what order they're in. You see that on the symbol, we don't always have to have those in order here. So let's take a look at another one here. You see that, again, the pin numbers do not always go in order, and even that 555 one that we had, they also did not go in order. So we're probably going to match the schematic that we have in that web page, and we'll make our own here. So first things first, we're going to go in here. We're going to make a new library, right? So this is going to be a custom library just for your part, just for the Getting to Blinky. So we're going to create a new library in here. We're going to call it GTB5. You can really call it whatever you want to. And you see that it's creating a .lib. So that's creating a brand new library. It's going to live inside your project directory. You see we're inside PCBs. CE is the folder that I have, and then Getting to Blinky 5.0. We did that in the first video. We're going to hit save. Now it's going to ask if you want to put it in global or project. I always do project because then it's just specific to this project. If you're going to have a general symbol library, you can definitely do that as well. That would be then at the top level. You might use that for every project in the future, but I'm just going to do it in the project level. And now we have a place to put our new schematic symbol, right? If we go, I think it's at the bottom here. Nope, it's going to be alphabetical. I always get confused. So we see GTB5, we click on it, there's nothing in it, right? So we can do this one of two ways now. We can go and we could say, I want a new symbol here, or we can right click and we could say, add a new symbol here, and that's what I'll do. Now we're going to actually have to name this thing, so we're going to call it 7555. Okay, we're going to do default reference designator, that's U, so like basically usually chips on a board are going to be U1, U2, U101, U201, stuff like that. And then everything else we're just going to leave as default. All right, and we're into the absolute basic part here. So now if I mouse over and I hit M, I can actually go and move one of these elements out of the way here. You see they're stacked on top of one another. I'll move the field value here, move that up a little bit. I can move this one down. You have to select this because there's when there's multiple things within the arrows region, then it's just saying, I don't actually know what you want to be moving here. Same thing, you could rotate it. So nothing else is in the way of that 7555. I can rotate it here. That's nice and easy. And then you can use other hotkeys in there as well. Okay, so first thing we're going to do is we're going to make this screen a little bit easier to see for you. And we're going to go like this. And so now we have this here on the side. And what we're going to do is we're going to replicate the same thing here. And actually, we need to go and get the pin names. And to do that, we're going to go into the actual data sheet. Now, data sheet is basically how we communicate what's inside of a component, right? So what are some of the functionalities? What are the absolute maximums and minimums in terms of what voltages can it take? What is some of the functionality? How do you interact with it? Basically, everything you want to know about that part will be accessible there. So what we're going to do is we're going to zoom in here on the part itself. And once again, this is the 7555. There's different ones here, I think, for, so this is SO8, which is one type of part, and this one's a DIP 8. So basically, this is the one that you might plug into a breadboard, and then this is the one that you probably would solder down to the board, and that's what we're going to do here. They should be, let's see, they are exactly the same. So they're just showing that on the side here, how they notate which side is pin 1 side is here. Okay, so we're going to do that. So first thing I usually do is I usually drop in all of the pins all at once. I just do them all at once, and I just deal with them. So I'm going to say pin 1 is ground, and there we go. Now we can also, this is often a common question as well, we can do the electrical type. You really don't need to. This will start to throw errors in the error rules checking, or electrical rules checking rather, or ERC. But you can mark everything as bidirectional and it'll work fine. We'll go ahead and we'll do it here. You do not have to do this, but we're going to do it just to be thorough. So we're going to say trigger. I'm going to actually shorten some of these things here. So I'm going to say trigger. And now you see that there's a line over top, and that means actually that it's active low. The way that we notate that is we put a little tilde in front. You see it actually marks the top there as well. We're going to call that pin 2. Okay, we're going to say out. It's pin 3. Reset. We're going to say RST. You'll often see that notation there. That's pin 4. Control voltage, so we'll say CTRL. That's basically just like it is on your keyboard there. Oh, and I haven't been changing these inputs here. So we're going to say that's pin 5. We'll change this one to just a regular input. See, this is where I start to not like doing this kind of thing. Output's obviously going to be an output. We'll change that to an output. This is going to be an input. Nope. Mouse over and I hit E in order to edit it. Once again, mouse over, hit E to edit it. Okay. And we'll just keep going here. I'm going to select the pin thing to once again start drawing new pins. Don't worry about the orientation. We'll deal with that later. That's pin 6. Actually, let's just make that, THR, threshold. Sure. Discharge, we'll just call it dis. Now, this is very capable. We actually can, if we want to, we could just type out the entire thing in here. I'm just used to doing it, shortening these things up. Sometimes the names get in the way. And then this one's going to be power input as well. Okay, great. So now we've got all of our pins here. I'm going to go back to this diagram here. And we're going to actually orientate these in the exact same way that we have them in the diagram. So what I'm going to do is grab these individual pins, and when we're connecting wires to these things, or well, schematic wires, I suppose, really the lines that connect one component to another, as we show here, we are going to connect it into the circle, and so that's the important thing to remember here. So we're going to move this. Sorry, I'm zooming kind of fast in here. My mouse is a little bit more sensitive than I'm used to. And I'll hit rotate, and I'm going to just try and match the same orientation that they're showing here. I'm going to grab 8. Okay. Usually I just try and get them kind of in the same general area as the drawing. That if I'm trying to replicate a drawing, then just the same general area. Okay, then we're going to put 6 here. Once again, you see I'm just mousing over, hitting M in order to grab the component and move it, or grab the pin in this case and move it around. So ground is going to be on the bottom. We'll move 3 to here. So you have to rotate this one around. And then I'll move these both to the bottom side here. Now you can orientate these really however you want to. At the end of the day, I'm just trying to make it so that it looks like exactly what we're looking at on this diagram here. So I'm going to now, this is the drawing tool. This is the rectangle drawing. Now in this one usually trips people up. You have to click once to start drawing, and then you start to drag without, you don't actually click and drag. You just click once. Now you see some of the stuff I didn't actually get all lined up properly. I can move those later. So I'm going to hit click to end drawing. And now move this one up. There we go. God, these were way off. And there we go. Actually, I'm going to move these up a little bit further. I guess I probably should have drawn that rectangle a little higher up there. Okay, I'm going to now go and modify this rectangle as well. I can hit G to grab. And once again, if you want to see any of these commands as well at any point, you can always right click, and you see the same thing here. Drag rectangle is G, but you can also just click G or click the drag command if you want as well. Now I'm going to go and edit the rectangle. I usually like to put in a background color. I think it looks a little bit more like a schematic symbol. And I'm going to grab this once again. I obviously did not do that properly either. All right, and it looks like we're pretty good here, right? So we got pins 1, 5, 3, 8, 4, 7, 6, 2. Okay, these all look pretty good here. Now, before we move on, I just want to say it is very important to keep in mind that the pin numbers, this is where you're actually creating, what's hooked to what. That's really what schematics are all about. What pin of this device that we're talking to, or that we're trying to implement in our design, what pin of that device is going to hook to the pin, say, of a resistor or a capacitor. In the case of like a resistor capacitor, there isn't polarity, so it doesn't matter which side of the resistor or capacitor you might hook it to, but it does matter which pin of the 555 you hook it to. So it is important to replicate this exactly. I find the most common errors that I'm making in my projects are not necessarily a wire that I'm drawing on a layout that's wrong. It's often that I didn't pay close enough attention to what I might be looking at as a reference point and then putting into my own schematic. So definitely keep that in mind as you're drawing stuff here. Okay, so we're going to hit save. What we now see is that this, on the left side here, we see that this component is available for us, right? Now if we want to go back in, we can always edit the symbol, right? If I move anything here, keep an eye on this here as well. Say I just move this down a little bit, right? Now you see there's a star here showing that yes, you have edited things. Now you might say, well, I know that I'm editing things here, but sometimes you've edited multiple things and you don't know it. You might have edited other things in different libraries that you've added yourself. It's nice to show that this has not yet been saved. If I hit Control S, that does do save. And I think that's it. Okay, so we've made our first schematic symbol. Oops. Once again, I'm going to drop a component into the actual schematic now. Like I said, you can do it up here for place symbol, or you can hit A to load up that dialog. Now I'm going to type in 7555. And here we go. We see our GTB5. We have our own here. All right. So we've created our first symbol. You do see that sometimes these move outside of the component itself. Personally, I like to have them on top of the component. I think that's a little bit simpler. Again, that's going to come down to maybe what your company's doing or what you're used to doing. But we've basically now replicated at least the symbol in the middle here, and we're good to go. The question mark on the U, that'll come up later when we're actually assigning these to the when we actually what's called annotate the schematic, and that'll give it a number, probably U1. So if you have any questions, you can always go over to contextualelectronics.com. If you didn't know, this is part of contextualelectronics.com, and we have a page over there. We also have a forum where you can discuss this, and you can always discuss in the YouTube comments down below. That's all for now. In the next video, we'll be going over the actual schematic, finishing that up, and getting ready to move you towards getting to Blinky. Thanks for watching.